Welcome to Journeys in Jupyter Session 101, the Python Data Ecosystem. If you've already set up the setup instructions, you'll have Anaconda installed on your system. You will have your presentation files on your desktop. If you haven't done that, check the introductory video 001, basically the Anaconda setup. So either click on your start icon in the taskbar, or you can just go to Anaconda and start up the Jupyter Notebook. You'll get this console window that spins up. It'll be rather ugly, obviously, and then your web browser will come up. You don't need to, just leave the browser window be for now. You don't need to worry about that. This is going to be the way that we interact with this presentation. It's all going to be done through your web browser, which makes it fairly easy for you. It's mostly point and click, with some minor exceptions that we'll get to. This is basically for navigating through your file system. So we're going to the desktop where our presentations are. We are going into the 101 Python Data Ecosystem folder, and then we're going to Introduction. That will bring us into our presentation, where you can basically just point and click all the way through. So, welcome to the Python Data Ecosystem overview. Theo Nonheim. This is tested on Anaconda. So first off, this is just a general overview of the Python data ecosystem. The software that you've installed, Anaconda, contains the Python language, as well as a bunch of data analysis packages and user interface packages that we're going to use to interact with Python and the Python kernel. So this is Python. It will be pandas, which we're going to get to. It's going to be NumPy and a number of other libraries that we're going to discuss at length. What I want to tell you in advance is don't worry if you don't understand this code. This is basically meant to give you a high-level overview as to what's out there, and whether you can follow along or not is just immaterial. Just follow along. You can execute the code as we go. Whatever makes sense, assimilate that. Whatever doesn't make sense, just know that you'll learn it later on. So again, don't worry if you don't understand the code. If you haven't already downloaded Anaconda, which I hope you have, please do so. It's free. These hyperlinks as we go through will actually take you to actual web pages. So they're all good links as of the last time I checked. So a lot of these links have really good foundational materials that are frankly better than what I'm giving you here. So as we go through the I think they're called extra links or extra data at the bottom of the pages. Just go to those links and learn what you can. I'm sorry, it's additional learning materials at the bottom of each section. So again, our goal is to give you a super high level overview of Python data analysis tools. Basically, one of the things that I ran into when I just started was I didn't know what was out there, so I didn't know where to focus my efforts. Again, you won't understand the code, but this will show you what tools are out there and the manner in which they can be used. This is just a general table of contents, for lack of a better term, of what we're going to do. We're going to look at Jupyter, which is this user interface here. We're going to look at Python, which is the language underneath that undergirds the entire Jupyter ecosystem. We're going to look at Matplotlib, which allows you to plot graphics and such. NumPy, we're not going to spend a lot of time on. SciPy, additionally, we're not going to spend a lot of time on because it's not going to be all that important to you getting started. But it's important to know that it's there because it's underpinning the language. And then, in addition, we're going to spend a fair amount of time on pandas, which is your day-to-day, how you're going to interact with the data. It's the API through which you're going to interact with data. We're going to go to scikit-learn, which does machine learning, model validation, etc. And then we're going to touch on some other things as we go forward. So if you would just click on Jupyter, right-click, open a new window. We're going to start with Jupyter, and you can go back and close one introduction because we don't need it, and then pull Jupyter up to the top. So this is Jupyter. Jupyter documentation and Jupyter homepage here. What is Jupyter? It's a HTML-based wrapper around Python. So basically, just think of it as a kind of a web page on your computer. Note that it's hosted on your local computer. You're actually hosting a web server, and you're basically interacting with Python via your web browser, which is pretty cool. It's comprised of a series of cells. You can see that we can go up and down. You can think of that a lot like You can think of it as a relational database, or you can think of it like Excel. You can do whatever you want in these cells and do it one at a time. We like this because we can not only put Python code in it, but we can put in Markdown, which is a really simplified way of putting HTML together without actually coding HTML. Or you can put HTML proper in, or you can do LaTeX to do mathematical formulas and the like. And as you go through, feel free to double click on any of these and tweak whatever you want and see how it operates and goes as you go forward. Most importantly, this will allow you to execute Python code within the individual cells, which is quite useful. We're not going to spend a lot of time on it, but these cells will default to code mode. If you're in a markdown mode, they'll present like this, and you can't execute them. See, if I were to put this in code, if I were to put this in markdown mode, it would be nonsensical because it's just Python code. So this is just a cell that feel free to do whatever you want with that, just for the hell of it. Onto actual Jupyter. So Jupyter is fairly intuitive. You can see it's a lot like any other web app you've used in your life. You've got menus, you've got save icons, etc. The only things that you need to know is that there are two modes for this. You can do a command mode or an edit mode. And so the too long did not read version, escape will take you to command mode, which allows you to do commands for the notebook as a whole. For example, I just added a cell because I was in command mode and I entered a command. If you press return, you see that it turns green, this bar right here, and it takes you to edit mode, which allows you to edit the contents of a particular cell. You can also go to edit mode by just double clicking a cell. That's a little bit easier. Shift enter or shift control runs a cell. So if I were to change this to this del was just executed, I could press shift enter and I would execute that cell. Or I could press Control Enter and I'd execute the cell without moving to the next cell. In addition, if you're in the command mode and you press H, there's a help dialog that comes up, and then Control Shift P can take you to your command palette, which you probably won't worry about all that much. For this presentation, as we mentioned before, all you really need to do is click on stuff and press Shift Enter to execute commands as we go. So basically, this was what I was telling you about before. Feel free to click on this cell above to put it into command mode. Click twice if you want to put it into edit mode. Put whatever you want in there, and then try to create a new cell using escape B, which is what that command is. Again, you don't need to memorize any of this because all of this stuff right here just gives you escape B would be right here. Escape and B is insert new cell below. Again, cell to tinker with is above, shift enter to run stuff. Looking at the toolbar above, it's a lot like other toolbars you've seen in other applications. So if you click on this, you can change the name of the notebook. If you press the disk icon, you'll save any changes you want to this folder here. It saves it as a .ipynotebook file, IPYNB file, which is just JSON or JSON, depending on your pronunciation. The file menu will basically give you things for saving, exporting, creating new notebooks, etc. If you wanted to create a new notebook, you could just do that. Edit is for cutting, pasting, etc. View, probably won't need that, but I mean, I might take the header off so I have more space going forward. Insert, fairly simple, just insert cells above and below. It's easier to use a shortcut, but if you don't know how, you can use the insert menu. Cell allows you to run all your cells, so if you wanted to run all the cells, you could do that. It allows you to clear your output, things of that nature. Kernel, you probably won't have to mess with this because nothing we're doing is computationally intensive, but if you run into an issue and you need to make your kernel crash and start over again, you can do that. Help, don't worry about widgets for now. Help, you can get reference to all the documentation you'll need. Python, IPython, NumPy, SciPy, Matplotlib, SymPy, Pandas. One side note, IPython is the old name of the Jupyter Notebook. It is now Jupyter Notebook, or if you're cutting edge, there's a Jupyter Lab interface that's even better than Jupyter Notebook. But this is kind of the lingua franca of data science, for lack of a better term. And you will be probably using this to interact with other people's notebooks as well. So again, we talked about Start menu, Jupyter Notebook, how you would get to this. This is our We also have this file browser window, which is what comes up immediately. It can give you a list of your running kernels, etc., but we're not going to spend too much time on that. I'm not going to get to this, but just know that you can't go up higher than the parent directory in which the IPython notebook is started, which can be confusing. And so what? What is this thing? It's a web app-ish thing that's not actually connected to the web. It's on our computer, so how does that benefit us at all? So the thing that I like about it is that it's great for iterative development. So I can do a pipeline approach. I can assign something to a variable, and then I can tweak that variable and capitalize it, and then I can get the result. So while that's a trivial example, when you get to actually processing data, being able to make changes to your data, transform your data, and then look at your data, plot your data, and then export your data is kind of a big deal. If you don't like the result after you did your first transformation, you can change it again, go back. And we've done this all without compiling any data or any serious processing. We just basically go back and we run our commands as we like, and we can do whatever we want. So one thing I will caution you on, the layout of the cells doesn't matter. You notice that after I execute a cell, I'll get a number. So if I do A, the 20th command that was run is there. I can do B, and then I could put whatever I want in B. If I went back to this B, it wouldn't matter what the old B was, because it's the order that it's executed. So basically I put something in B, I went back up, I put something in B again, but because it wasn't done in order, I get the old one instead of the new one. So another thing that we like about this is this has support for Matplotlib and IPython, which is great because a picture is worth 1,000 words a lot of times. So we can basically just go through and plot as we go, get our input, and that can inform our analysis as we go forward. And then in addition, it is directly tied into the Python ecosystem, and you can use whatever you want within the Python ecosystem, such as emailing, FTP, whatever you want, and you can make it work. A couple of things that I've got here. This gallery of interesting notebooks is actually fantastic. There's a Jupyter Quick Start Guide, and there's a DataCamp tutorial. This gallery of Jupyter notebooks has pretty much everything that you could ever think of. So it's got all these notebooks that give you examples of whatever you want. It's got everything from NFL data to climate change data, whatever you want. And it's all interesting stuff. Moving on to Python, which is the language underneath the Jupyter Notebook, we're going to go forward. I'm going to go back and close this close this notebook because we no longer need it. And then I'm going to go to IPython, and Python rather. So the Python documentation is actually really good, especially the standard library documentation. I highly encourage you to go out there and look at what's in the standard library because it's really, really good. In addition, there should be, if I haven't put it down at the bottom, the official python.org tutorial is really where you want to start if you're not familiar with Python. It takes you from the very beginning all the way to intermediate stuff. So going back up to the top, this is Python. What is Python? It's a general purpose programming language that focuses on simplicity and clarity. And it's, for our purposes, it's the glue that allows us to put different elements of the Python data analysis stack and allows them to communicate with one another. It's stupid simple to understand, and it's a language that allows people to be productive by doing stuff fast. And increasingly, it's taught more and more often in computer science courses as a first language, simply because it's a simple language and easy to learn, but it's still flexible enough to be powerful. One side note, Python is an interpreted language. If you go to your Anaconda folder and you were to open up the Anaconda prompt, type Python, you can A equals 5, A plus 1. You don't have to compile anything. As you go, the language dynamically figures out what you're doing, and it makes sense of what you're doing. So you can put in these commands interactively, which is great. It's called a read-eval print loop or REPL. So what is IPython? IPython is building on top of Python, and it makes it adapts the Python interpreter for interactive use. So it's got things like auto-completion, inspection, and special functions that allow it to be better suited to this Jupyter Notebook environment. And again, as we mentioned before, Jupyter Notebook used to be the IPython notebook before it branched out to other languages like R, Julia, etc. I think there's even a Sass kernel, which seems kind of weird. But so what's Anaconda for then? Anaconda is a free Python distribution, so it's just a nicely packaged collection of Python and other software that you could get elsewhere if you wanted to, but the Anaconda people put it into a nice installer and they make it available for you for free. And they also support a lot of awesome projects, so you should support them if you're in the position to do so in an enterprise environment. So while you could get all these packages elsewhere using pip, which is the Python package manager, it's easier to just download Anaconda and do that. So what can we use Python for? Web programming. Django is a popular web framework. PyQt for GUI programming. System administration and scripting is also a place where it excels. Data analysis, SciPy, etc. And then basically, if you look at the Python package index, there's a ton of just things that you can install. People put their packages out there on the internet for free, and you're welcome to use that. Again, a couple things about Python. If you aren't aware, Python uses indentation syntactically, so I'm not going to get too in-depth into this, but instead of using braces like you would in a bunch of languages, C, Java, etc., you use basically indentation to do scope. So if you have an if statement and it doesn't work, it's probably because you didn't indent it. Comments are done like this. You do assignments with equals, and I'm just going to get to a couple common constructs as we go. So basically, this is how you would put 5 into a variable, A. That's how you define a variable. You can say 5 equals to 5 using the double equals for equality. That basically just says 3 plus 5, 8 equals 3 plus 5. So you would get true out of there. And whatever's on the last line will be what you get out of a cell. So if I have a comment, you'll get a comment out. Functions, so they're the foundation of any real language. So if you want to define a function and you want to put something into it, if you don't want to type that code over and over again, you can make a function using this def keyword, taking your input there and returning a value out. So this is basically a function for functions give input and output rutabaga. Loops, you've got loops, so you can just go through for every item in this list. I want to print the item times 5. We did that. We've got indexing like other languages, so if you want to get the first item of the list, if you want to get the last item of the list, if you want to get the first and second item of the list, if you want to get the first item to the end of the list like that, or if you just want to get the end of the list to etc., you would use this syntax here. We've also got exceptions, which are fairly easy to do. We've just got our try-catch blocks. And then if you want to get into object-oriented programming, we can have classes, methods, etc. So a couple of things that we want to talk about for IPython enhancements. If you ever see a percentage sign at the start of a cell, it's where you wouldn't see it otherwise. It's safe to assume that you're triggering what's called a magic command, and I didn't make that name up. These commands let you do pretty much whatever you want. The most important one you'll see is this matplotlib inline, which instead of plotting in a new window will allow you to plot in this existing window. And here is time, or time it rather. So this basically allows you to time how fast a cell runs, so it gives you an idea about how efficient your code is. One thing I'll talk about, autocomplete. So if we have a variable and it has to have been run and it has to be existing, we can basically just say period, and then it will autocomplete whatever we want. So if I just type text period, I have the ability to hit the tab button and do autocomplete, and then I can just get, let's say I want the count of the letter A. And so there are 2 letter A's in I am a text string. And then the last thing I'll bring up is the help window. So if you ever put a variable or a type with a question mark after it, you'll get this help window that'll come up and give you information. Because text is a string, it gives me information on strings. And then the dir method gives you all the methods, or all the attributes and methods, or basically anything that is associated with this text. So if I wanted to see what functions exist, you can see what functions exist, and that would be it. Again, the official Python tutorial is fantastic. I highly recommend it. Google's Python class isn't bad. There are a couple of other ones I've got on here, but I really would point you to the official Python tutorial if you haven't started with Python initially. So moving on to the matplotlib section of our presentation, I'm going to close PyPy. I'm going to close the Python portion of the presentation, and I'm going to go to matplotlib. So this is your matplotlib API, the Wikipedia page if you want to learn about it. This gallery has a bunch of images that have been made with matplotlib that give you an example of stuff you can do. And it's, for example, if you went to any of these, you could get the actual code used to generate these graphs. So if you see something you like and you want to imitate it, this is a great place to start. So what's matplotlib? It's a Python-based plotting library that supports a lot of different types of graphs, kind of a MATLAB-like API, and it integrates with the IPython notebook, and it can be used for pandas for easy graphing operations. And if you're just getting started with Python and the Python data analysis stack, you're probably going to be using pandas directly, and you won't directly be, you'll be using pandas and you won't directly be using matplotlib. So what kind of graphs do we have? Line, area, bar, hexplot, hexbin, whatever you want, and any arbitrary combination of the above. So if you wanted to have a bar graph that had a line graph superimposed on it, or you wanted to have 50 pie graphs right next to each other, you could do that. How do we use matplotlib? Again, as I mentioned before, you're probably going to be using it via the pandas data analysis library first, which we'll get to in a little bit, but it's just going to be as simple as I import my data, and then I say, data, I want to plot you. And so I can plot it using just data frame plot method. As we mentioned before, we import matplotlib, our library. We import pandas. And then this is what we were talking about before, where if I don't want a graph in a separate window, I want to use inline. This is just me loading the data, and you can read the comments as to what I'm doing. And then it plots as simple as dfplot. I think that the default styling is a little bit ugly, so I use 538's blogs. So basically modeled after Nate Silver's 538 blog. And again, this plot method is pretty versatile. So this would be an example of, I basically say plot, I want a histogram with 30 bins, or I want 50 bins, etc., or I want 2 bins, and it would be terrible, but you could basically just plot hist, and you would get your data frame plotting using pandas and not using matplotlib directly. Here's just some of the more stuff you can do. You can change your line style, your marker, your color, the width of your line. You can annotate your graphs automatically or manually if you want. And then as you go, you'll probably learn more about Matplotlib and be able to use it directly. The one things that you'll want to know, again, check the documentation, but you're going to want to import PyPlot as your basically plot as your toolbox. Your figure is going to be your basically your entire graph, and then your axis is going to be this portion here, the x and y axis data associated with that, and then other stuff as well. The get current axis and get current figure functions are also very helpful. So this is just an example of us taking Matplotlib, PyPlot, and we're importing plot. We're clearing everything. It's just so to be safe. We're getting our figure and our axes. And then we're basically just doing a scatter graph, and then we're plotting a line plot on top of it. This is an example of us superimposing. We basically plotted our scatter, and then we plotted a line. And then this is just a slightly more complex example where I'm changing the color of the points, changing the line style, making the face white, which apparently isn't necessary. It automatically defaults to white. And then fig. And then here I am just adding a title, adding some sort of tick labels. It looks like I'm adding a legend. And then I apparently save this to the folder. So save it to data output. So we've just created an output of our paint, maybe? I don't know. Yeah, so we just created a output. So it's saving your figure is as simple as fig, save fig, and then the file path that you want to save it to. And then, I mean, you can get as complicated or as stupid as you want with this, obviously. This is an example of a silly graph. If you're looking for something kind of Tableau-like, there's really no substitute for Tableau, but there is this package called Bokeh, which will allow you to put together plots, interactive plots, that will, here, I don't know what this does. So I can change the year, I can get ET, the extraterrestrial, alien, etc. Bokeh can run on a server. You can do whatever you want with it. We've also got Seaborn, which provides additional types of graphs, such as violin plots, heat maps, and other items. So this is an example of a violin plot. This is an example of a heat map. You can really do whatever you want with plotting. So I would recommend the PyCon tutorial, the Matplotlib tutorial, and the PyPlot tutorial. They're all good, and I think I found another tutorial that I liked. And then so on to NumPy. We're not going to spend a ton of time on NumPy because you're not going to use it directly, but just know that the NumPy reference guide and API is there. So it's basically just a C-based extension that allows you to do all this fast stuff, all this mathematical stuff really, really fast. Python is an interpreted language, so it's going to be slow compared to your C++, C#, and Java. The way that Python got around that was basically just do everything in C. And then it has since become an integral part of the Python data analysis stack. So Matplotlib, SciPy, and Pandas all depend on it. So what are we going to use it for? Probably nothing when you're getting started, but you'll need to know about data types and ND arrays for certain types of machine learning analysis if you get into that. This is basically just a demonstration of creating an array, reshaping an array, and then reshaping it again, doing some rudimentary mathematical stuff. Again, Pandas will do most of this for you. A couple of useful functions and methods. So if you ever want to create a regularly spaced interval of numbers, this is how you would do that. I want 0 to 5 at 9 steps, so 0, 625, 125, all the way to 5. NumPy arange, which would basically just be I want to step from 0 to 5 by steps of 5, not dividing it up into equal steps. Polyfit for your linear regressions, quadratic regressions, etc. I'm sorry, exponential regressions. vectorize for making functions vectorized. There's a faster way to do this, but I'm not going to get into that. Concatenate for concatenating arrays. Argsort, which is kind of amazing. I think it's awesome because you run an operation on an array and it will give you the order in which it will be the sort. Basically, it'll give you the sort order. So this would be A would be first. Z would be, no, I've got this wrong, but I'll get to it later. And then NumPy random normal for doing statistics stuff. SciPy does statistics as well, but this is a quick way to generate a lot of numbers randomly around a normal distribution. NumPy Quick Start, PyCon videos are generally pretty good. You can take a look at those. I'm moving on to SciPy now, which I'm also not going to spend a ton of time on because you probably won't be using it. And I have a bad link in there, and I will fix that. So there was a 0.6 in the link. It should have been a 6. So what's SciPy? It has a large number of scientific computing tools, so linear algebra, calculus optimization routines. What are you going to use it for? Probably nothing, but here's an example of SciPy Optimize. It gives you the minimum value. SciPy Stats, you'll probably not need to use it because it's overkill, but if you want to do ANOVA or you want to do Kolmogorov, Smirnov tests and stuff like that, that's where you would look. This is basically just probability of the random number on a curve less than 12 is 0.93. And this is just, we created a curve, probability curve, we did a sample, we got the probability density function all the way up and down, and then we did some other stuff as well. Oh, and then we got the cumulative density function and then plotted that for a particular number. So introduction to SciPy, NumPy there, SciPy lecture overviews, and then we're going on to pandas, which is where the fun stuff starts to happen rather. So closing that, moving on to pandas. So what's pandas? Again, API reference, I will go to this specifically because the API is huge for pandas. It will do anything you want, anything you can think of. Anything that's worth doing, pandas has probably done for you already. So what's pandas? It's a data library that focuses on data manipulation and analysis. And while it was designed as an econometrics platform, it's made its way into a variety of domains, lots of science and signal processing, fancy things. So two important concepts. Pandas, if you're familiar with the statistics language R, pandas stole a lot, and that's a bad link, I'll need to fix that. Pandas stole a lot of it from R for good or for ill. It stole this concept of a data frame, which is basically just, you can think of it again like a table. You've got indexes on the side and on the top, and then you've got basically columns and rows. So you can get this for example is a row of complaints from this Consumer Financial Protection Bureau or Bureau of Consumer Financial Protection under Mulvaney's watch. And so you've got a column of products. You've got, I don't know, we've got thousands of samples, but we can get the product for each, we can get the issue for each, etc. And it's just a way of organizing data like a spreadsheet. But we've got a lot more available to us. So here we're just importing all of our libraries. We're loading this data with the read CSV function, which is pretty easy. And then we're just going to take a look at this, this data that we've loaded. Again, this can be thought of as like a relational database or an Excel sheet. It's got rows and it's got columns. The rows are going to correspond with any individual observation, item, or entity. The columns are going to be your features or your various features of the individuals, of the features of the data set. They are not in Navy, but I'll get to that later. And so why do we even want that? Because we can do a lot of cool stuff with it. And then the other thing that I want to take us to before we move on is the concept of a series. It's just a list of it's basically just a single column from this data frame. If you look at date received 0, 1, 2, and if we look at product, we've got credit card, credit reporting. Here we've got 0 credit card, 1 credit card, 2 credit reporting. It's basically just taking a look at this product and inspecting it individually. So what can pandas do? If you're a Python person, I readily admit that this syntax is kind of weird. And that's, if you're not used to this from Python, that's a perfectly normal reaction because brackets generally aren't used like this, but by abusing this getItemMagick method, they were able to do some really cool stuff, which I'm going to get to. So what can we do with this? If we want to take our data frame and we want to cut down to a particular set of columns, we can do it by feeding it a list like this. So basically we cut our data frame down to product, company, state. This head function will just give you the first 5. You can also do tail. It's just easier than looking at the whole thing. We can also get using the loc and iloc methods. So if I want to get let's say if I want to get the second element, I could do it like that. Or let me get the whole data frame. So if I wanted to get the second element of the whole data frame, I could do that. Then we can also do Boolean indexing, which I'll get to in a bit. So if I want to say, I want to look at all the data frame where the company is equal to Citibank, I just put whatever I want into here, and I will get out a filtered data frame. One thing that I will point out, it's called Boolean indexing. If I just analyze this on its own, you'll see that I get false, true, false, 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 which is basically just this. Because Citibank, is it Citibank? False. Is it Citibank? True. Is it Citibank? False. And what I can do with that, if I feed that to a data frame, it will filter out all the rows that I don't want, and it will give me the rows that I do want. And that's called Boolean indexing, or fancy indexing. Again, I didn't come up with that name. A lot of times when I have an index that I'm going to use, you'll see it referred to as Bix. So we can just do Bix equals this, and then TDF Bix, and it would be the same thing. So moving on, if we wanted to filter on American Express, and the other thing I wanted to say is we can do this iteratively, so I can filter down American Express, store it in this filtered data frame variable, and then I'm going to pull up the filtered data frame. And then if I want to do analyze it further, I want to look at the states and I want to get the value counts for the states, I can get that. And then if I just want the top 5, I can do that too. That's the other way. Sorry. Top 5 would be like that. So that would be the top 5 value counts for the American Express company. We can also examine our columns or our series individually. So you can see that I'm basically doing a method on the series. Whenever I have a data frame and I have a column after it, that'll be a series, and you can see that we've got a series like that, and then we can do whatever we want with it. So we can do unique, and we can get all the unique values that would be in there. Series and data frames have a ton of methods. Again, take a look at the APIs and have some fun. Again, let's see, we did unique. That's nothing. We can also get the data types. In this case, it's just object, which isn't going to be all that interesting. Hopefully the original data frame, yeah, so we've got some integer objects, some float objects, etc. The other thing you can do is group by functions. So I want to group by the product and subproduct, and then I want to find out information about that. So for example, I group by product and subproduct, and then I check the mean on that. So I want to say bank account subproduct CD has a mean of 34,000. Bank account or service, cashing a check, median of 33,000. And then I can get down to checking account CD, you only get 2,000. Consumer loan, installment loan, 4,500. And then you can graph from there. So here's an example of how you might graph that. And then again, picture's worth 1,000 words. You can see that bank account or service, very high. Other stuff like CD, bank account or service is high. Checking account or service is low. Consumer loans are low. And this is all fictitious data that I made up with a random distribution, but this gives you an example of how you can process, go through, sort your values, plot it, and get whatever you want based on data as you go through. You can unstack it. So before we had size. If we want to unstack it, we can do that, which basically takes this subproduct where it was right here, and then it flips it up top so you can get it as a cross tabulation. You can also do what's called aggregations. So this is basically just, so for my group by, I want to get the median, max, mean, the min, and then the range. The range is an arbitrary function that I made because I took the max. I basically took this column and I took this column and I subtracted the min from the max and I got the range. So as you can see, you can add or you can transform these columns in a vectorized manner, basically just meaning that you can I can take that and then just by multiplying it by, say, 99, I can make it huge, and I just multiply the vector, or I multiply this column by 99 instead of having to go 395 times 99, etc. So I can do that with columns too. I can do output. I don't remember what the other column was named, so I think it was a min. Yeah, so I can multiply my columns together. I can subtract my columns. I can do whatever I want with them. And I don't have to do it element by element. I can just do it on a column basis. In addition, we can run our custom. Let me actually make it a little bit. Let's do it 0 to 5. I can make custom functions. So I can basically say, I want to, for a given row, I want to go through all these rows one by one. And I want to say, this is a problem with rewards for credit cards from the state of Texas received on X date. And I want to do that for each and every row in the data set. I can do that by creating a function, basically complaint, and then the ID is the type of complaint from the state of state. And then I basically just apply that function all the way down, and in a matter of, we went through however many hundreds of thousands of records. It would be better if I didn't chop it off first. So I went through 10,000 records in less than a second, and I basically just said, for each of these complaints, I now have a nice string that I can use. And I'm just going to iloc 0. And this is an example. So complaint, the first one in the series is complaint 2682743 is a credit card complaint from the state of Texas. Again, we can read stuff. This is basically just reading a data frame, and then we're reading this data frame, and then we're going to merge it with our data frame. So we basically merge the date from the CFPB data frame with the other information from this simple data frame, and you can just think of it, you can do inner, you can do outer joins, left joins, etc., and it's just this really easy way to join two data sets that were unconnected before and bringing them together. And then again, if you want to write it out, you just do output to CSV, and then we can see our data, and then hopefully we've got, yep, the transmogrify output is right there. So we can see our data is right there. So we've also got the ability to do time series analysis. So this is basically, we are going to convert this date received to a nice date time that we can manipulate in a complex manner. We're going to group them by the day of the week, and then we basically just say we want the number of the days of the week, and then we plot the days of the week. So it looks like most complaints for the Consumer Financial Protection Bureau are uploaded on Wednesday or Thursday, and then comparatively, or maybe that's when they come in, I don't know, but there are comparatively few on the weekend. Let's sort first. So they come in mostly on Wednesday, then Tuesday, then Thursday, and then they don't come a lot in on Sunday, Saturday, etc. In addition, so you can do all kinds of fancy stuff. This looks like, so I'm setting the index to the date time. I am grouping by the product. I'm doing a rolling 7-day window, and then I'm getting the mean. So this is the rolling 7-day window for credit cards, consumer loan, and credit reporting. And then as you can see, they stabilize over time, but your credit card products, 7-day mean, are fairly high. Your consumer loans are low, have low variability, and then your credit reporting is low and has low variability as well. And then this is all just making it shiny. Text mining. So if you noticed up top, there are complaints in just plain text. So I was offered a gold card and they didn't give me what I wanted, things of that nature. So we can mine that text. For example, I want to find all the entries that contain the word lawyer, and so I basically just run it. And again, we went through 10,000 entries in less than a second, and then we basically just said, I want all the items containing lawyer. I want the first one, and then hopefully, if I did this right, I should have the word lawyer in here. Sent to my lawyer, who seems interested in why this has happened. So, and then as you can see, if I get the data, this would be all the complaints that have the word lawyer in it. Let's see how many I have. Out of the 10,000, I had 162 that had the word lawyer in them. It can be more complicated than that. If you're familiar with regular expressions, this can really get as complicated as you want. This is basically wild cards on steroids. So you can, I want to get capital L, lowercase l, lawyer to the end of a sentence, or capital A, lowercase a, attorney to the end of the sentence, and then we basically just run that. And so I get, let me get the first one. So lawyer who, that's not helpful. Oh well, let me try print. Oh well, that's frustrating because I'm messing up. So basically we got lawyer to the end of the sentence. Attorney General's office, we weren't looking for Attorney General, but it matches the pattern, so we got attorney to the end of the sentence, lawyer, and then it'll go to the end of the sentence. And then so we just extracted the pattern that matched this, and then we put it in a data frame. Pandas from the ground up, I cannot say it enough, this video changed my life. Take a look at this. 10 minutes to pandas is an excellent place to get started, but I, again, would recommend that you advance to pandas from the ground up. Next on to scikit-learn. So scikit-learn is machine learning. API reference here, documentation and user guide there. It's a library that provides a consistent and painless API for a number of common machine learning algorithms. And for our purposes, you can think of machine learning as taking models and making mathematical models from data. So here are here's a number of lists of the types of algorithms that are supported. Note, neural networks are not optimized. If you want something that's done on GPUs, the TensorFlow and Keras, actually I think Keras is closing down. To use TensorFlow, and you can use GPU optimized neural networks. Caveats, I'm not an expert on machine learning, so view all my claims with suspicion. We're not going to be going behind we're not going to be going into the mathematics behind these algorithms. If you want that, this textbook is pretty good. And if you're in any sort of financial institution, make sure you follow your model risk rules. So what do we use scikit-learn for? We basically want to do a classification in which we determine a discrete variable, or we want a regression where we look for a continuous variable. So if I want a classification, it would be discrete, like male or female. If I wanted continuous, it would be 0.5, 1.3, negative 2,000, etc. So this is just a graphical illustration of the process steps we go through to create our model and do a prediction. This is just an example. So for example, if we go out, we catch a lot of fish, we find out this is 700, 5 meters long, it's a shark, 100 kilos, 2 meters long. It's a cod. The big fish are sharks, the small fish are cod, etc. We basically transform it into feature vectors, which we're going to refer to as X, and then we use Y for our targets, which is shark or cod. And so we can basically take data and we can create a model that will allow us to look at things we've never seen before and guess whether they're a shark or a cod. And this is our test data set. This is an example of the steps you would go through, and then we use fit transform to create our models. Normally you want to normalize your data. I have another presentation on machine learning if you want to take a look at that. This is just going to gloss over most of that. We fit transform our data, and then we basically just use it to predict a classification. So here, this is a lot to look at, but just this, we scale it, we run a logistic regression, we input our data, and then we fit our data on the, we supply our data and fit it on this training data here. And then we use it to predict, and then as you can see, the big one was a shark, this was a shark, the middle one that was small was a cod. So these are the probabilities of shark and cod given our logistic regression model. And then this is just a graphical depiction of what we did. So we drew this decision boundary. All of our cods are down here. All of our sharks are up here. And then as you can see, it looks like length is a better discriminator than weight. We've also got pipelines, and this is just an example of another thing you can do. This is going to be a classification problem, so we're taking the CFPB data and we're getting all the complaints and we're predicting the type of complaint based on the text in the complaint. So obviously credit card, the word credit card is probably going to be associated with credit cards, and we're going to basically transform this feature vector into numbers that the computer can understand, and then supply this as our target. So we basically just create our pipeline. We've got a vectorizer, a transformer, and a classifier, and then we want to basically fit our data. So we fit our data, and then we have some dummy data that I've just created. Bank of America are jerks, they screwed up my mortgage payments, and we want to test to see if our model works. So we can see that this comes away. Our machine learning model predicts that the first one is a mortgage complaint, which makes sense because it's got mortgage in it. And it's obviously a lot more complicated than that, because home would probably home would probably figure into the equation. Loan modification probably figures into the equation. The home affordable mortgage something program would figure into the equation to differing degrees, and it varies. The second one has credit card in it. And then this third one is just kind of a canard. This has no real value as far as a complaint. And so it looks like the dumping ground, bank account or service is basically the dumping ground for nothing else. We can validate our results given scikit-learn, because there's a lot of facilities for doing that. We do our train test split. We can see that our accuracy was 70%. We can do cross-validation scores, and I shouldn't have done that. That was really dumb because that will take forever. And then we can do cross-validation as well, and that is just a deprecation warning, so that's not a problem. I'll be fine. And then this is hyperparameter selection. We're not going to get into that because this would take, well, actually I'll just get that started, and maybe it'll be done by the end of the presentation. This will take a long time because we are basically doing cross-validation and hyperparameter selection, so we're just iteratively testing all the various parameters we could feed our, oh, actually that was much faster than I thought. Okay, so our best parameters are hinge loss using IDF and then n-gram range. And this initially was a joke, but this actually is not a bad place to start for picking out whatever scikit-learn model you want to use. I highly recommend Jason Vanderplas's talk. PyCon 2015, Jason Vanderplas is my hero. Scikit-learn getting started is good, and then other useful stuff is good. So before we close, this is just the Machine Learning 101 that I recommend. So other items, there's a lot more rolled into Anaconda than you're probably aware of. So Beautiful Soup is for screen scraping. If you want to get web data from the internet and you want to basically go to a web page, get all the information there, pull it in and process it, you would use Beautiful Soup. Bokeh is for interactive graphs. ComTypes is for hooking into ComTypes in Microsoft Windows. So if you wanted to automate something in Microsoft Word or Outlook, you could do that. Cython can compile your Python for speed. Flask is a web framework. Natural Language Tool Processing Kit is the NLTK, which has natural language tools. Excel files can be used. Just a side note, don't use Excel files. Save to CSV files if you can, but if you absolutely have to save to an Excel file, you can use these facilities here. If you want to connect to databases using ODBC libraries, you can use ODBC, and then you can use PyQt if you want to do a GUI framework. PyWin32 lets you do hooks into the operating systems. Requests is okay for doing web requests. Seaborns we discussed. SQL Alchemy is for object relational mapping. And then I don't recommend stats models, but you can use that if you want. Other Python standard library modules that you may want to use: Async.io for asynchronous processes, collections for, weird collections, copy for deep copy, datetime, there's good datetime support, decimal, if you need true decimal arithmetic, not floating point arithmetic, you can look at decimal, email for sending emails, itertools for chaining stuff, and other iterable stuff, JSON for dumping JSON strings, functools for functions, IO for IO, like building text or byte strings, OS for interfacing with your operating system, Pickle and Shell for serializing things, RE for regex expressions. There's a built-in SQLite 3 database that I go into in my automation presentation that you can use to store stuff. Subprocess for subprocessing, sys for tweaking your interpreter, threading and multiprocessing for multiprocessing, and XML elementary for doing XML. So that brings the presentation to a close. I highly encourage you to look at my other presentations as they go forward and they get developed, and thank you very much.